Hello everybody. In this video, we would learn how to name cycloalkanes, which are alkanes in a closed ring form. Now, if you remember in the previous videos, we started talking about the ways of IUPAC nomenclature, and we had listed out a couple of steps for doing so. Let's just have a quick recap of what we've learned. So in the first step, we identify the parent chain, and then we name and number the substituents. The numbering should be done in such a way that the substituents get the lowest possible number. We attach counting prefixes if necessary, and then we write the whole name, which is the prefix, as all the substituents involved, then the parent name and the suffix, which in case of alkanes is "-ane". So, if we talk about the rules again, the substituents are written in alphabetical order and numbers are separated by commas and numbers and letters are separated by dashes. Let's just recap with an example. So, for example, in this compound here, we see that all of the carbons are bonded by single covalent bonds, which means it is an alkane. Now to find the longest chain. So here, if I start from this carbon on the end, we can see that this one is the longest chain. You can pause the video and find out the longest chain if you need to. Now to go ahead and look at the substituents. We have a methyl group here and an ethyl group here. So to number it, we have to start from this side, because again, we number so that the substituents get the lowest possible number. And finally, we end up writing the name, where we write all the substituents and their position numbers first in alphabetical order and then continue to their parent. So in this case, ethyl E comes before methyl's M. So we have 3-ethyl, 3-methyl hexane, and this is the name of this compound. If you have any queries, you can go back to the video of the nomenclature of alkanes. I will link it below in the description if needed. Now, we've also seen that when representing an organic compound, we use the expanded structure formula or the condensed structure formula. Now, for now, we have been using these ones specifically, where in expanded, all the bonds are shown, and in the condensed formula, only specific bonds are shown. Now, for cycloalkanes, it is easier to use skeletal formulas, where bonds are shown with lines and the endpoints are carbon atoms, or each point where there is a vertex, we consider that to be carbons, and the hydrogens pertaining to the carbons are not written. Now, let's just have a quick example. Cycloalkanes will look like this. So, in this triangle, you will see that there are 3 vertices, and these 3 are the carbon, and the straight line here represents a single bond. In reality, this is what it would look like if I were to write the expanded structural formula. So you have 3 carbon atoms and all the remaining valency spots are filled with hydrogen, and these hydrogens are not represented in the skeletal formula. So this one is a structure with 3 carbon atoms. So this is basically a propane structure. In this one, it is a structure which corresponds to butane. Here you have a structure with 5 carbons. And this one you have a structure with 6 carbon atoms. Now let's look at the nomenclature part. The ring is the longest chain that we have. Then only one change is done. We add the prefix cyclo to it. And then we have the normal parent, which goes meth, eth, prop, and so on. And then the suffix, which in this case is all single bonds, which is "-ane". So for the first compound, this will become cyclopropane. So you can already guess what will happen to this one. This is cyclobutane, which is butane in a cycle. This one is cyclopentane. And as you know already, this one should be cyclohexane. Now, what if they have substituents attached? Let's look at that. When monosubstituted cycloalkanes are named, then you do not have to number the positions. All the positions in the ring are equivalent. Now, you might be wondering what monosubstituted means. That is, only one substituent is attached to the main parent ring. For example, in this case, so we have one methyl group attached to this cyclopropane. So this can be one attached to cyclobutane or examples like these. Let's try naming them. You do not have to number if there is only one substituent because all the positions are equivalent. So this one would be methyl cyclopropane. Similarly, this one is methyl cyclobutane. Now here the substituent is not methyl. You can guess this is ethyl. This one is ethyl cyclopentane. Now, can you tell me what this one is? It is methyl cyclohexane. The last thing that you have to keep in mind is, what if there are more than one substituents attached? All you have to do is now go back to numbering these groups. The only thing to remember is, the first position goes to the first one in the alphabetical order and proceeds in the direction so that the next attached group gets the lowest number possible. What do I mean by this? Here both of these substituents are methyl, so it doesn't make a big difference. You can number 1 and 2 because this will be the lowest possible numbers, or 1 and 2 conversely, and the same rules will follow. This one is 1,2-dimethyl cyclopentane. What about this one? Again, we follow the same rules where we write the ones which is alphabetical first, and in case of cycloalkanes, we just give them the numbers first. So in this case, chloro comes before methyl, and now the numbering starts here. And now you have to proceed in the direction so that the next substituent gets the lowest possible number. So this is the position number 1. And now here you will have position 2, position 3 and position 4. And it's quite easy to guess the name. We start from the alphabetical series, 1-chloro, 2-methyl cyclobutane. What will be the name of this one? This also has the same series where there are two different substituents attached. You see, in a cyclopentane ring, you have an ethyl group and a methyl group. So the numbering starts with ethyl and then continues in the direction which gets the least number for methyl. If you were to do it in the opposite direction, this would have been 1, 2, 3 and 4. So you go in this direction only. So now we go again and name this compound. Here we have 1-ethyl, 3-methyl cyclopentane. This one is another example where you have 3 substituents and the naming system follows the same. Chloro comes first, so that gives the first position number. And here you will have 1-chloro, 1,2-dimethyl cyclohexane. Now before we leave, I'll just leave you with one simple question. Name this compound. Please leave your answers in the comments below. Until next time, happy learning.